All right, so we're going to look at estimating derivatives of a function at a point, and we're going to be using our calculator. We're going to estimate the derivative with a calculator. In the calculator, we're going to be using the calculator menu with math. The menus are math and then number 8. We'll see that in just a minute, but you might want to highlight that for future reference there. All right, so we want to find, we're given a function, f of x equals sine of the square root of x. We want to find f prime of 2. So we want the derivative at x equals 2. Now, in the calculator, you're going to notice some notation that's a little bit different. So when we say find the derivative, we can use this function, or this notation, I should say, d dx. This is saying find the derivative of your function with respect to x. And so in the calculator, it's going to look exactly like that. It's going to say d dx, find the derivative with respect to x, and then we're going to type in sine of the square root of x. And then the calculator is going to give this little notation. It's going to say x equals, and we're going to pop in the number 2 right there. So let's do that. Let's go to our calculators, grab your graphing calculator. So again, we're going to start on the main page here. We're going to go to the math menu right here on the left. You can either scroll down to number 8 where it says n derivative, or you can just hit number 8 and you get your notation here. There's the d dx notation. We only use x in here so we don't have to worry about the other parts. We want to type in our function sine of the square root. Let me see, we need the second key in the square root button. We're going to type x in there, and then we're going to go over here and we're going to type in x equals 2. And the calculator is going to tell us, hey, it's 0.0551. Remember, we need 3 or 4 decimals in this class, so I'm going to say that this is equal to 0.0551. That was easy, right? Didn't have to do all that work that we did the other day. All right, the next one says, if f of x equals the log of 1 over 5 minus x, find the derivative at x equals 1.3. So again, the notation in the calculator is going to look like this, d dx. And again, what that notation is saying is it's saying, find me the derivative with respect to x of the function ln of, we're going to have a couple of sets of parentheses here, 1 over 5 minus x. So we're going to close that. We're going to close that. And then the calculator is going to give you this little x equals, and we're going to type in 1.3. Again, here we go. Let's try this one. Where's my calculator? There we go. All right, so we're going to go math number 8. We're going to type d dx. All right. Then we're going to type our function. I need a log function that is right over here. I need a fraction, so I'm going to go to alpha y equals number 1. That puts the fraction in there for me. I'm going to type 1 over 5 minus x. And then I'm going to go outside. And I believe I need another set of parentheses in there somewhere. Yep, right there. There we go. Got to make sure you close them or you might get an error message there. And we're going to do this at 1.3 for x. And we're going to hit enter, and the calculator hardly even needs to think. We get 0.2702 as the derivative. 0.2702. So what we are saying is, if we were to graph this function, okay, if we were to graph f of x, and we were go to the point at 1.3 and draw the tangent line, that tangent line is going to have a slope of 0.2702. That's what we're saying there. All right, the next one says, write the equation of the tangent line to y equals, and then we have this square root function, x over x cubed plus 1, at x equals 1. There are 2 things you need to write the equation of a tangent line. You need a point, and you need a slope. You will notice this time we only have the x value of the point. We need to know the y value of that point. This one I can just plug in. So I'm going to find y of 1. That's going to equal 1 over 1 cubed plus 1. That is inside of a square root. And the reason I did this one like this is because it's pretty easy to see that inside that square root, you're going to get 1 in the numerator, you're going to get 2 in the denominator. So we've got the square root, square root of 1/2, which could also be written square root of 1 is 1, but the square root of 2 is still root 2. So you could write it either way. It doesn't matter. I think I'm going to leave it the second form because I like that. So now I have a point. I have the point. Let me slide this over a little bit. So my point is now 1 comma 1 over the square root of 2. There's my point. So I need a point and I need a slope. Now the slope for this guy, we haven't learned how to do this yet. So we're going to look at the slope using the calculator. So we're going to go back to our calculator again. We're going to do d dx of, let's see, I make sure I write this correctly here, x over x cubed plus 1. And I would encourage you to stop the video and try this one on your own. See if you can remember where those keys are at and all that kind of good stuff. Let's go ahead and do that. I'm going to hit the math menu again. Number 8 for derivative. I'm going to type in x d dx there. That's saying find the derivative with respect to x. I need my function now, and I need to type in my function. So I need, first of all, I need a square root. Then inside of that square root, I need a fraction. So I'm going to hit alpha y equals number 1. I'm going to type in the numerator, which was x. I'm going to type in the denominator, which was x cubed plus 1. Oh, need to get out of the exponent there. So plus 1. And then we need to go outside and we need to plug in the value of 1 for x. And there we go. So this function actually has a negative slope tangent line. And so the derivative here at x equals 1, the slope at x equals 1, is negative 0.1767. All right, so I have my point, I have my slope, I need to write my equation. Y minus y1, that was 1 over root 2, equals my slope, negative 0.1767 times x minus x1, which is 1. Check it out. There we go. All right, so our next thing we're going to look at is estimating derivatives from a table. Remember, a derivative is just a slope, okay? So in order to estimate a derivative, the function must be differentiable. Okay, and what that basically means is that the graph is continuous and smooth. Remember, to be differentiable, you can't have any sharp turns and you can't have any vertical tangent lines on the graph. So basically, we need to be a smooth curve. Okay, so it says use the table to estimate f prime of 3. Show the work that leads to your answer. So if I go back and look at my table, first of all, I realize in the table there's no 3 up there, but there is a 2 and a 4. And if I have a t-table and that's all I have, then I can't even choose a number really close to 3 to use. So I have to use 4 and 2. So when it says estimate f prime of 3 in a table, that means number 1, the slope at 3, the slope at x equals 3. So again, it's just an estimate. And the way we're going to do that is we're going to do the slope formula using x equals 2 and x equals 4. Just like we were doing the other day when we were estimating slopes using slope formula. So I'm going to do f of 4 minus f of 2. That's my y2 minus y1 over 4 minus 2, x2 minus x1. That's going to be 10 minus 3 over 4 minus 2 is 2. So we're going to end up with 7 halves. Now, is that a great estimate for that? Probably not, but that's okay. It's all we have right now, so we're just going to estimate. That's all you can do. All right, second one's pretty straightforward then. Use the table to estimate the derivative of W at 100. Show the work that leads to your answer. Again, you go to the table, there's no 100, but there is an 80 and a 120. So again, I'm just going to simply do f of, oops, this is W, excuse me, I'll use the proper notation here. W of 120 minus W of 80. And I do realize that I'm writing some extra stuff here. I'm just trying to get you used to the notation here. Over 120 minus 80. So W of 120 was 500 minus W of 80, which was 700. All over 120 minus 80, that's going to be 40. So I'm going to end up here with negative 200 over 40, which tells me my slope is negative 50. Or negative 5. Sorry about that, negative 5. Okay, so that's all we're worried about doing is how to calculate that. Good luck with your homework.